Hi student, welcome to this video on generating set. Now, after we covered vector spaces, subspaces, now comes the notion of generating set, which will be based on vector spaces and subspaces. Now, let V be a vector space and S a subset of V, written as this. Now, we say that S generates V or span V if and only if span of S equals to V, right? I know you may ask yourself a question. What's the meaning of span of S, or span of a set of vector? So, the span of a set of vectors, right? Now, since vector spaces are closed under addition and scalar multiplication, therefore, we should have a name for the set of all linear combination of a given set of vectors, and that will be their span, right? So, what are we trying to say? What we are saying is that the span of a set of vector is the combination of the set of all linear combination of the members of the set of vectors. Okay, so a space generated by S consists of all linear combination of members of S. Does that make sense to you? Right? So, if therefore we write that, let's say I, that span S equal V, then we say that S is a generating set of V, or that S generate V. Okay, hope you are getting good here now, right? Now, and you must therefore understand that the span of S, you understand that the span of S, right, is therefore the set of all linear combination of vectors in S, right? So, and we already covered the notion of linear combination. Now, let's therefore try to understand what we are saying by solving a practical example. Find a generating set for W equals to X, Y, Z, X plus Y plus Z equals 0, and Y plus Z equals 0. Okay, how will we solve that? Solution. Right? So, we can write these two in terms of a matrix, right? Because it can be X plus Y plus Z equals 0, and Y plus Z equals 0. So we can extract matrix A over here, which is 1, 1, 1, and 0, 1, 1. Right? Okay? Yeah, and then you have to note that X, Y, Z belongs to W, right? And also X, Y, Z belong to the null space of A, right? Because this equation is the same as AX equals to 0, isn't it? Yes. Then what we are trying to solve here is that we want to find a vector or vectors whose span will give back W. So the main idea to solve this question is that we want to find a vector or vectors, right, whose span gives back W, right? So at this point, we have to find the reduced row echelon of A, right? Having A 1 1 1 0 1 1, right? If all I have to do is to do that, or R1 equals to R1 minus R2, this will lead me to 1 0 0 and 0 1 1. Okay, so having this, right? I can see that I will have that x equals to 0, and I will have that y plus z equals to 0. So x equals to 0 and y equals to minus z, right? So therefore, I will have that x, y, z equals to 0 minus z, which is z 0 minus 1, 1. So as you can see that, therefore, the null space of A, which is solution of equation Ax equals to 0, will be equal to span of 0 minus 1, 1. Okay, so when we ask the question, find a generating set for W equals to this, so we come to the conclusion that this therefore will be the generating set. Right? Okay. So if we have another example, example 2. Example 2, we say that what is the generating set of S. So with S equals to 1, 2, and 3, 6. So their solution is simple and very straightforward. You have that the set of all possible linear combination is the generating set. So the generating set written as this will be alpha 1 2 plus beta 3 6 with alpha and beta element of R. So in this video, you were able to define what we call a generating set, and then define the span of a vector, and then answer the question how to find a generating set for a certain vector space. In the next video, we will do more practical exercises on the generating set. Thank you.